out, and then I'm gonna share my screen. All right. All right. This is the notes from yesterday, I guess. Okay. So yeah. So we're gonna have a couple of exercises before moving to the next section. So we are still in section. This is a section 6.2. It's binomial distribution. All right, so very quickly, I'm just gonna remind you what's a binomial distribution, how to find the probability of binomial distribution, and then we're gonna have a couple of exercises. So just to remind you the idea here. So so when you have a binomial experiment, so we're gonna have like two outcomes. First, you have a success, so S, that would denote the success, and then failure denoted by capital F, and then there is a probability of success P, lowercase p, and there is a probability of failure, lowercase q, and then we said Q, probability of failure, this is always 1 minus p, because you either succeed or you fail, right? So Q plus P is equal to 1. All right, and then there is a fixed number of trials given by N. So N, this is the number, fixed number of trials, And then we said the goal is to find the probability of R successes out of N trial. So to find capital P of R, so this is probability of, this is the probability of R successes of R successes out of N trials. And then we said to find this probability of R, the probability of R successes, we actually use the table number 2 in the formula sheet. To find this probability of R successes. So again, guys, the formula sheet, it's on CUNY Blackboard. Let me share again with you the formula sheet. So it's right here. So this one here. So if you go to CUNY Blackboard and you click on the formula sheet, then you can download the formula sheet. So so the table, it's actually, so it's not the first page, not the second, but in the third page, right? So it's called the table 2, right? In the top, it's written table number 2. And then, so in this table number 2, as you can see, so you have your, as you can see in the top, there is P, right? This is lowercase p in the top. So we have like this is like the different probabilities of success. And then there is N, right? And next to N, there is R, right? So so actually we are using this table from the formula sheet to find this probability of R successes. So as you can see here, for N, the values of N, so it starts with the N equal to 2, then there's a 3, 4, 5, 6, 7. Then like in the next pages, you have like 8, 9, 10. But actually the highest value of N in this table would be, so 15 here, but then 16, and then I think the last value of N is 20, right? So actually there's some values missing between, like here between 16, N is 16 and N is 20. You see, so there are some values missing, like I don't know, like 17 or 18, etc. But guys, in the either in the homework or in the test or even the final, right? So for sure you're gonna have some problem, at least one problem about this binomial distribution. But so either the test or the final, the value of n is gonna be in this table. Okay, so you don't really need to use like the other formula with the this n choose r, etc. So the value of n that you're gonna need in the test or in the final is gonna be in this table. Okay, so you need to know how to use this table, and please let me know if you have a trouble to find to use this table. Okay. Anyway, so we're gonna do a couple of exercises so you can see if you know how to get this probability of our successes from this table. All right, please guys, let me know if you have any question, right? So we're gonna do, as I said, a couple of exercises from the textbook, and then we can move to the next section. All right, so let's do, so let me see, textbook. So let's do exercise 20. So this is exercise 20, page. And again, guys, if you want to get the textbook, I can send you a link where you can download the PDF file of the textbook. All right, so this is exercise 20, page 271. And it says the following. So there's this study. The study shows that approximately is 10% of all businessmen who wear ties wear them too tight. Okay. Now it says at the board meeting. So there's this board meeting of 20 at a board meeting of 20 businessmen. Okay. All of whom wear ties. Wear ties. Find what's the probability that all right, so first, so we have like 4 A, B, C, D. So A, B, C, and then D. So in A it says at least one tie is too tight. Oh, okay, at least. Well, probably one tie would be too much. Let's say at least 19. Say 19 ties are too tight. More than let's see. So it says more than well, it's just take different numbers here. More than 17 ties are too tight. No more than 3 ties are too tight. And the last probability is, let's say, no tie is too tight. No tie is too tight. Right? So before solving the problem, guys, I'm gonna discuss how do we solve such a problem. Okay, so whenever we have like this binomial distribution problems, so as a first step, whenever we have this binomial distribution problems, so as a first step, step one, I mean, before answering any question, so step one, you need to find the probability of success P. Well, first you need to understand what's a success. What will be the success in this binomial experiment, right? So first, as a step one, so we need to define, or we need to, clarify what will be a success. So what's a success? So what do we consider as a success in this problem, right? What's a success in the problem? Right? And then you need to find the probability of success, P. You need to find the probability of success, right? And then you need to find N, the number of trials. Okay. So before answering any question, right? So you need to understand, or you need to, you need to clarify what will be a success in the problem, what's the probability of success, and what's the number of trials. Okay. So, let me read again the problem. So it says a study shows that approximately 10% of all businessmen who wear ties wear them too tight, right? So what will be a success? Like, so here we are interested in the businessmen who wear ties, right? And so a success. So if you select a random businessman, right, then either the businessman wears the ties too tight, yes, and that will be a success. And if the ties are not too tight, then that will be a failure, right? So from the first sentence, guys, so from the first sentence you can deduce what will be success and what's the probability of success. So here there is this percentage, right? This is a 10%. It says 10% of all businessmen who wear ties wear them too tight. So this 10% should be your probability of success. And the success would be a businessman who wear ties too tight. Okay. So this would be your success. And this would be your probability of success. So usually, like in this kind of problems, in the first sentence, you're gonna see some percentage. So that percentage would be your probability of success. Okay. Like in the first sentence, you see a percentage, that will be your probability of success, and you can find also your what will be a success in the problem, right? So yeah, so like in this problem, this 10% should be your probability of success. That's your percentage. That's the probability of success. And so success would be a businessman who wears ties too tight. So in this problem, a success. So you select a random businessman. Select a random businessman. Right? Who wears ties? Okay. So either the ties are too tight, right? Or they are not too tight. Okay, so then the probability, so this would be the success, and this would be a failure. So then the 10%, this 10% would be your probability of success, right? That's the percentage of businessmen who wear ties too tight. Okay. So probability of success in this problem, P, is 10%. Okay. So again, just from the first sentence, you can find your probability of success. The percentage in the first sentence, that will be your probability of success. And of course, I mean, if you want to find the probability of failure, it's not really important here because we can just use the probability of success to answer all the questions, right? You don't really need to find the probability of failure. But anyway, just for your information here, of course, probability of failure, that will be 1 minus P, right? So 10%, of course, that's the percent means division by 100. So 10%, that's a 0.10. So Q, that's 1 minus 0.10, which is 0.90. Anyway, so we know what's a success now. We have our probability of success. We need to find the number of trials N.
20.
20, right? Because we have this group of 20 businessmen, this board meeting of 20 businessmen, right? So usually like the number N, the number of trials would be the next sentence after, I mean, the second sentence in the problem. First sentence, you can find your the probability of success. The second sentence, you can find your N, which is the size of your samples. And here we have 20 businessmen. So N is 20, absolutely. So in this problem, N is 20 because we have a group of 20 businessmen. We have a group or a meeting of 20 a group of 20 businessmen. All right. So once you get your probability of success and your N, now you can move to this next step and you can answer all of the questions, right? Once you have your P, your probability of success, right? You have your P and you have your N, then you can answer any question. All right, so now step 2, we can move to the questions. Now we can answer the questions. All right, now, so let's do the A. So we have A. So let me just, again, just remind you here. So we are saying P is 0.10 or 10%. And number of trials is 20. All right, guys. I'm gonna give you some time to think about this, the A, B, C, and D, right? Because I think we discussed similar examples yesterday. So I'm gonna just give you a couple of minutes to answer A, B, C, D. So let me.
Always count the 0. Let's say if we have to find out more than 3 numbers, does 0 also count on the chart? When I say 0, what R is?
Yeah,
R,
I mean R. Yeah, I mean you need to count R equal to 0, of course. Or you're talking about the like if the probability is given by 0.30.
Yeah, to be specific, the no more than 3 ties are 2 tie.
Mhm.
If I do, if I count on the section 20, I count
Yes.
1, 2, 3. Do I also count the 0? And that's what
Oh
I'm asking.
yeah, of course. Yeah, that's a very
Okay.
good point. You always, yeah, don't forget that's like a common mistake.
Okay.
You need to count the 0, of course. The 0 is included. Absolutely.
And the probability?
Yes, in the
Okay.
probability. Yeah. So let me show you where you should go in the table, guys. I mean, if you're kind of lost, let me show you just the table here. Again, you can find the table on Community Blackboard. So so our N, we said it's 20, right? We have 20 a group of 20 businessmen, right? So we need to go to N equal to 20. So as you can see, like in this page, N is 8, 9, and 10. So we need 20. Next, it's 11, 12, 15. This is 16. And here is last value of N. As you can see here, I don't know if I can click on this thing here. Okay, it doesn't work. All right, not a problem. So here, the last page in the table, so you have your N equal to 20, right? You see here, your N is 20. But then next to N, there is R, and R goes from 0 to 20. Right. And
Professor, I'm lost
yes,
over there. You're on number 20, I see. And then you have,
yeah.
what columns are you looking at?
The second,
0.01?
yeah, the second column. So after the 20, there is so the column next to 20. You see there is 0, 1, 2, 3, 4, 5, 6, 7, etc. It goes to
Oh, going straight
20.
down.
Yeah, yeah, down, yeah, all the way
That's
down.
how we
to
read
20.
it?
Yes. So that's how you read R.
Oh, okay.
So okay, so what I'm saying is like, oops. Okay.
It's not like a multiplication
So what I'm saying
chart. You
is,
go across, you have to go down.
no,
all
no,
the
no, no, no,
way.
no, 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 no. It's not like a multiplication. So what I'm saying is, let me just open this file here. All right. So you see the 20. There's right here. There's 20, and then next to 20, there's like 0, 1, 2, 3, 4. You know, it goes
Yeah, I had
all the
seen
way
that. I
down.
seen that.
It goes all the way down to 20. All right.
Okay.
Now,
But that's how we always read it. Like we're going down, never across.
no. So to read R, you need to go down. You see, so here I'm going down. So this is like the all the values of R.
Okay.
So you need to go down to read all the possible values of R. All right.
Okay.
So that's for R. But then, all right. So for example, if you want to answer the first question, so what does it say? The first question says like, at least 19 ties are 2 tied, right? So what does it mean? At least 19. At least 19.
Professor,
Yes, please.
I can't see your screen.
Oh, you cannot see my screen?
I can't, no.
Do you see my screen, guys? Anyone else?
Yes, I can see it.
You can see my
Yes, I
screen?
can see it, Professor. I can see it.
All right.
I'm gonna try to leave and come back in. Maybe I fix it.
Okay, I mean, I'm sorry about that.
That's all.
So yeah, so the question A, it says, it says like at least 19 ties are 2 tied, right? It says like at least 19 ties are 2 tied. So then 2 tied. So because of the word at least, right? We said at least means the minimum. The minimum is 19. Is 19. So we have a group of 20 people, right? So if the minimum is 19, then so it could be 19 or 20, right? So here we are looking for the probability of R, the number of successes is 19, right? Plus R equal to 20, because the minimum is 19. So it could be 19 or 20. So first I need to find the answer for R equal to 19. So as I said, so to find the R, you need to go all the way down. So I need R to be 19 first. So here's R is 19, okay? And then the P, our P in this problem is 0.10, right? P, we said it's a 0.10. So then, like in the top, we need to find the 0.10. Like in the first, the first row, in the first row, you can see there is like, it says like N, then there's like R, and then there's like 0.01, and then like 0.05, and then there is like 0.10, 0.115, like, right? Like in the first, the first row, 0.15, 0.20, etc. We need, so in our case, it's 0.10. So here's my 0.10. So then we need to go all the way down where R is 19. Okay. So what do you think the answer would be here, Kayla, for R equal to 19? If you check the table.
I can't see the table.
Oh, okay. I'm gonna share with you the table. Okay. So you go all the way down to 19, but then you need to take the value which corresponds to 0.10.
Yeah, I'm at 0.10 and okay, you're
And then-
zooming in.
Yeah, so 0.10. So you need to go all the way down to where R is 19.
Oh, okay, all right.
So what will be the value?
I'm looking right now. I see 0.185. I'm in the right column, right? 0.185.
Yeah. So you see
329,
Yeah,
right?
so then, but those values correspond to n equal to 16. You see the n on the left side, it says n
Yeah.
is 16. But in
Yeah.
our case, our n is 20. So we need to go all the way down, to 20, where n is 20.
Yeah, I'm looking. I don't even see it to be 20. I just see all the big numbers on the top. Then you got like what,
Is the number that's sticking
1.014.
out?
Yeah,
I
but
don't-
yeah,
On
yeah,
the end
0.04.
column, there's the number 16 is sticking out of the rest of the numbers are going down. And then on that same
Mhm.
row, all the way down, there's the 20 that is not part of the column that the numbers are going down. It's like they divided by sections. So it's like 20 and all 0 to 20 belongs there. 16, 0 to 16 belongs there.
Yeah, because that's
So-
because I'm looking, I'm like, I don't see that nowhere. I
So-
see 0.16 on line 7, but when I'm looking down, I don't see any
0.16.
20 anywhere.
No, the 20 is the very first column. You see that
Oh,
there's
yeah,
n
right.
in the
Oh,
top.
okay, I'm sorry.
The
You
very
have to
first.
find the column,
So it's
the
122.
first.
Yeah, like there's a 16 in the top, and then if you go down, there's 20. It says like 20.
Yeah,
But
and then you go
the
over. Oh, okay,
yeah.
all right, I'm sorry.
That's the
122.
where. So that's your n where equal to 20.
Thank
but
you,
then-
Yana, too. Thank you.
But then you need to find the R, which is equal to 19. So next to 20, the next column, you see there's 20, and then next to 20 there is like 0, but then you go down, there's like 1, 2, 3, 4, 5, right, all the way to 20.
Yeah.
So then you need the R is 19, so you need to go to R equal to 19. So you need to go to 19. So you need to go to the bottom. In the bottom, you see there's 19 and then 20, right?
Mm-hmm.
So our R is 19. Okay, so you take that row where R is 19. Okay, so next to 19, what do you see next to 19?
0.000.
0, absolutely. And then there's another 0.00, then there's 0.00. It's actually
You have to go to the column.
yeah, bunch of 0.000, and then the first non-zero, let's say, number is like 0.002, right? And then there's like 0.007, 0.021, etc.
Yeah.
Right?
0.058
You see that?
and all that.
Yeah, 58. All right. Now, which one are you gonna pick? The thing is, your probability of success, P, we said P is 0.10. We said that there's a percentage, 10%. Probability of success is 0.10. So you need to go, up, like the very first.
Is it 0.85?
No, well,
0.185?
no, that's
Oh, damn.
0.185. That's when N is 16. Your
Oh, okay,
N is
okay.
20. So you see the point, yeah, you see the
Oh,
point
okay, so it's
185.
0.28, right? That's where N is 20. Oh, no, that's R. That's R.
Yeah,
No,
you just
so-
have to look at the section of the 20. So now you remember where he said that the 20 is sticking out? Just look at that, look at that square of numbers. And then you go
All right, so just use the left-hand column.
this
Because
paper,
it's
I suggest
16,
that we
it's
all print it
20,
out.
and then you just go, you go across.
Yeah, you go across. But
Yeah, no, I got
but
it
then,
now.
yeah, but then you see the column where it says 0.10. So then your the answer would be the third 000 next to 19, right? The next to 19, we said that there is 0.00, right?
Yeah.
So that 0.00 corresponds to 0.01. So if you look to the top, the first row in the top, it says 0.01, right?
Yeah.
But then, okay, so the next 0.000 in the top, it says
Belongs to-
0.05,
Mhm.
right? And then the third 0.000 in the top, it says 0.10. You
Oh,
see
okay,
what
I
I mean?
see it.
So that 0.00, that's your answer, because your P is 0.10. So
Oh,
okay, okay. Let me do it again here.
maybe it's just
So-
me. I don't know.
Sure.
I'm the only one
No,
having
I
a
mean, it's-
problem
I
with
think
it?
you
A
should
point with your arrow
print
when
it out.
you're doing it.
When you print out the paper, it will be better for you to like
Yeah,
visualize.
because I'm squinting and
Yeah,
Point when you're doing.
No, no. Well, let me just write down the numbers here. So probably it would be better. So like 4, 5, etc. But then there's this 19, and next to 19 there is this 0.000, right? There is another 0.00, again 0.00, etc. There's right 0.00, etc. Right? So the first, you see the first 0.00. So we said, like, if you go all the way to the top, you see that is 0.01, right? The second 0.000, if you go all the way to the top, like the first row, you'll see 0.05, right? The third 0.00, if you go all the way to the top, you'll see there is 0.10, right?
yes.
You follow me? Okay. So yeah, so that's 0.10. That's exactly our P in this problem, right? Because we said P here in this problem, the probability of success is 0.10. So your answer should be this number here, because your R is 19, right? Your R is 19 and your P is the 0.10. That's your probability of success.
Oh, okay. I'm gonna
Okay.
print out the formula, Professor. I'm sorry, because
No,
my son was being a
no
little
problem. I mean,
distracted too.
but no, but because if you know how to use the table, then it's gonna be very easy to answer all the questions actually.
Oh,
If
yeah,
you know
no,
how
I'm
to-
definitely gonna be running back the video.
Yeah, but I mean, anyway, so if you still have trouble, we can we can have a meeting and we can you know we can
Okay, I
discuss it
appreciate
online.
that.
Sure. All right.
I apologize, you guys taking up your class time with the
No
chart.
problem. No. I mean, we are doing a lot of exercises today, so the point is to understand how to use the table. Anyone else has like a trouble with the table? Please let me know, guys. I mean, this is like the time where if you have questions, you need to ask them. Let me see the chat. Yeah.
I was just
you're right.
saying to point when you was showing the grid, because I have an idea, but I wanted you to point, because I saw when you was explaining to her,
Kayla?
to
Mhm.
Kayla, yeah. But I was trying to look,
Mhm.
but
Yeah,
I
so you
was
have a
getting
trouble. You don't know. Okay, you still don't understand how we got
the R.
the R. No, the R that's from that depends on the problem, depends on the question. So like let me show you here.
Oh, this here, I know this one, the probability. And
I'm gonna here. The R, we said R is 19 because well the question says like we need to find the probability that like at least 19 ties, right?
yes,
So we said the minimum is 19, so it's gonna be either 19 or 20, right? And
right.
then we said we need to go to n equal to 20. That's the very first column where you have your n. So the n is 20, and then next the 20 you have your r. So r goes from 1, 2, 3 all the way to 20.
Okay,
So but then we need r to be equal to 19. So we have to stop here at r equal to 19, and then check the values next to r equal to 19. So next to r equal to 19, we said there is like 0.00, then there is another 0.00. Actually, there's a bunch of 0.00, right?
yeah,
So, but then which 0.00 corresponds to our problem? So in our problem, we said that the probability of success is 0.10.
yeah,
So you see each value 0.00 corresponds to, if you go all the way to the top, you see the probability of success. You'll see
right.
there is a 0.01, there is 0.05, and then there is 0.10. So yeah, so that's why the answer would be this number right here, this one.
Okay, 10.
Yeah, it's yeah.
Okay, thank you.
So yeah, so yeah, so to answer the question here, so we have the probability that r is 19 plus probability that r is 20, and so we use the table, and from the table for r equal to 19, you get 0.000, and for r equal to 20, again here our p is 0.10. So for r equal to 20, it's also 0.000. So the answer is just 0.000, which is, if you want to convert it into a percentage, you will need to multiply by 100. So that would be just 0.
Yeah,
Okay. All right, so let's do the B. B, it says more than 17 ties are too tight. So when we say more than 17, so we do not include the 17. It's more than 17. So it has to be 18 or 19 or 20, right? So when we say more than 17, guys, here, more than 17, 17. So in B, this is B, question B. So it says more than 17. More than. So if it's more than 17, so it has to be, so it's 18, right? It's more than 17 or 19 or 20, right? The maximum, of course, is the 20 because we have a group of 20 people, right? You cannot have more than 20. So it's either 18 or 19 or 20. So this is like probability that R is 18 plus probability that R is 19 plus probability that R is 20. And again, use the table where N is 20. So here again, N is 20. Your P is 0.10. And again, in the table, well, it's again just zeros. So it's 0.00 plus 0.00 plus another 0.00. So the answer is just 0.00. So it's just 0%. So we are kind of unlucky here because the answers are just 0.00. Hopefully next one, no more than 3 ties. Okay, this is good because the answer is going to be not different from 0. So no more than 3 ties. So in C, so it says no more than 3 ties. So no more means the maximum, right? No more. So that's the maximum. So no more than 3 means that the maximum is 3. So the maximum is 3. So if the maximum is 3, then of course we need to include 0. So it can be 0 or it can be 1 or it can be 2 or it can be 3. All right. So what will be the answer like for R equal to 0 from the table? So it's not, so this time it's not 0.00, right? So so in the table, guys, again, I'm gonna just explain to those who are still have trouble with this table. You see the 20, and then there's 0, 1, 2, etc. And then next to 0, there's like 0.818, and then 0.358, and then 0.122, right? And then 0.039. So like for R equal to 0, so N is 20. This is my R equal to 0. So here's my my row. Okay. Now which number is gonna take? 0.818 or 0.358 or 0.122 or the next one? Well, so what we do, guys, just check the top, go to the top. So like 0.818, if you go all the way to the top, you can see that's in the top, it corresponds to 0.01. Now the 0.358, if you go all the way to the top, you see that it corresponds to 0.05, right? For 0.122, in the top, you'll see it corresponds to 0.10. And our P is 0.10. So our answer, the answer here should be this 0.122 for R equal to 0. Okay. Hopefully it makes more sense now. Let me see the chat if there's any. Okay. Yeah, you can see it here, like 20, next to 20, there's 0, right? And as I said, if you go all the way to the top, you see the probability of success be. All right, guys. So that's for r equal to 0. So the answer is 0.122. So let me just write down here again. So r equal to 0, 1, 2, r equal to 3. So for r equal to 0, that's 0.122. R equal to 1. So the next, so when r is 1 and p is 0.10, so we have 0.270, right? And then when r is 2, that's 0.285. And then when r is 3, that's 0.190. Okay. So yeah, so then the answer, of course, would be so 0.122 plus 0.270 plus 0.285 and plus 0.190. So the answer is 0.867, which is multiplied by 100. That's 86.7%. All right, guys. Last one. It says, where is it? D. No tie is too tight. So no tie is too tight. It means that your R is, again,
Professor, I have
R
a
that's,
question.
yeah, please.
If the homework was saying like no more than 10 tie, do we gonna have to check like R 0 to 10?
Yes, from
Okay.
0 to 10. Yes. Yep. Absolutely. So last question, it says no tie. Where is it? No tie is too tight, right? So no tie is too tight. R, that number of successes, that's the number of ties which are too tight. So no tie is too tight. So that's R equal to 0. So no tie is too tight. So then R is 0. And yeah, so R is 0 for 0.110. So we know the answer is 0.122 multiplied by 100. That's 12.2%. Okay. All right, guys. Okay, I think we spent like almost 1 hour on this exercise, but I think it's a good thing. I mean, because you need to understand how to use the table. That's very important for you. So what I'm gonna do now.
I'm sorry, Professor.
Yeah, please. Yeah,
The
please.
no tie is too tie. You said if it's no tie, what would you do? 1.
1 tie,
Yeah.
then R is 1. If
No, I know R is 1. I'm saying why would you do 1 when you say no tie is too tie? You're not counting any numbers, but I guess 0 on
so
R, you know, R0, not R1.
no, yeah, well, okay, let me just, well, R.
Oh, I'm so sorry. Yeah, you're right. You're right. I thought you had 2 numbers. I thought you had PR0, PR1.
No, R just 0. No,
R0. Yes,
yeah,
you're right.
just,
Sorry.
No problem.
Thank you.
Thank you. Yeah, so yeah, guys, I think we can probably move to the next section. And again, in the next section, we're gonna do a similar problem. So It's just a continuation of this section 6.2. So section 6.3. So it's about additional properties of this binomial. Properties of binomial distribution. So first, I'm going to show you how to graph binomial distribution. So how to graph binomial distribution? I mean, we did it like, you know, using the histogram. We graphed some, probability distribution of discrete variables. So here it's exactly the same thing. All right, so let me do an example just to remind you what's a probability distribution example. So let's say you take 6 shots in basketball, okay, and you think, let's say you think you usually usually make 50% of your shots. Okay. So let's say you want to find the probability distribution of this binomial experiment. All right. So you're gonna take 6 shots in basketball, right? So of course, when you take a shot, then either you're gonna make it, right? You're gonna make your shot, or you don't, right? So so you take a shot. So either you make it, and so that'll be a success, or you don't. Okay, and that'll be a failure. All right, so so what's the probability of success here, guys? So what's the probability that you make your shot? Well, as you can see, it says usually you make 50%, right? This percentage here, again, like the idea is like in the first sentence, you're gonna see some percentage, and that percentage, that will be your probability of success. So here it says usually make 50% of your shots. So your probability of success that you make your shot is 50%, right? So P here, probability that you make your shot is 50%. And again, percent means division by 100, so that's 0.50. Failure, all right, so the failure, probability of failure is just 1 minus P, so 1 minus 0.50, so probability of failure is 0.50. All right, anyway, so I'm gonna find the probability distribution of this binomial experiment. Remember, guys, what we said about in the chapter 5 about probability distribution. So what's a probability distribution? We said probability distribution, we assign for each value of X the probability of X, right? So here in binomial distribution, we don't have X. We don't have X. We have R, right? The number of successes. So we're gonna find the probability distribution of R. Okay.
So,
So
Professor, I have
here,
a quick
yes.
question.
Yeah, please.
For the 6 shots, that's
Mhm.
the 6 trials.
Yes, very good.
So
Sorry, yeah, I
how
forgot.
when I find those numbers on the chart, I calculate all the shots.
Yes, so yeah, okay,
Like
that's my next.
PR0, PR1, 2, 3,
Yes,
4, 5,
so
6.
that's what I'm gonna, yeah, that's what I'm gonna say like in a minute. Yeah, thank you. So the idea here, so this, to answer this question, so the probability distribution means that, so probability distribution, so what we do is of R, so we make a table. So we need to make a table where we have, like, first you have R, the number of successes. So because you're gonna take 6 shots, right? So R can be 0 or 1 or 2 or 3. R is the number of successes, right? That's so 3, 4, 5, or 6, right? The maximum value of R, of course, is 6, because we're gonna just I'm gonna take 6 shots. So the maximum number of shots, successes here is 6. And for each value of R, like we did for X in the chapter 5, for each value of R, you're gonna assign the probability of R. You're gonna find the probability of R. So like here in the first this first column here, we need to find probability that R is 0. And how do we do that? Well, use the table. N is 6, so you need to go where N is 6, and R is 0, and then your P, probability of success, is P is 0.50, right? So like, so let me just show you here in the table. So we need to go to N equal to 6. So here there's N16, and then all the way down there's N20. Here N is like, there's 11, there's 12, there's 15. We need to go N equal to 6. This is N 8, 9, 10. This is N, yeah, here. You see, so N 2, 3, 4, 5, and then 6, right? So here's my N equal to 6. And next to 6, of course, there's your R. So we need R to be 0. Now, our P is 0.50. So if your P is 0.50, so then the answer should be, so you go in the row where R is 0, and the column is P is 0.50. So as you can see, that will be 0.016, right? So yeah, when R is 0, the answer here would be P is 0.50. So it's 0.016. Okay, so where's my table? Oops. Where's my table? Okay, it disappeared for some reason. Okay. I don't see the table. Okay, well, I'm gonna just write again here. So probability distribution of R. So again, we said, so there is values of R, 0, 1, 2, 3, 4, 5, and then 6. And then there's probability of R. So we said when R is 0, our N here in this problem, we're gonna take 6 shots, right? N is 6, and P is 0.50. So for R equal to 0, we have 0.016. R equal to 1, we have 0.094. Next R, it's 0.234. Next R is 0.312. Next R is 0.234. Then 0.0094. And then for 6, that's 0.016. 0.16. All right. So this table, this is the probability distribution of my binomial experiment. Right. This is the answer. This is what I call probability distribution. For each value of R, you assign the probability of R. Okay. And again, guys, I got all these numbers from my table number 2. Any question? Let me see the chat, if there's anything in the chat. Okay, nothing in the chat. All right. All right, guys, that's the probability distribution. For each value of R, you assign the probability of R. We can, of course, graph this probability distribution using histogram, right? So let's graph of a probability distribution. So as usual, just use a histogram. Right. So what we do is, so we're gonna have a horizontal axis with the values of R. So like R is 0, then 1, 2, 3, 4, 5, and 6. And then here you have the values of the probability of R. Right, so we have like smallest value, I guess, that will be 0.016. Then there is this 0.094. Then there is 0.234. So there's 0.234. And then there is 0.312. Right, so then for R equal to 0, for example, you know that P of R is 0.016. So we take the interval with this the middle given by 0. So like this blue interval where the middle is 0. And then you draw like a rectangle with the height equal to 0.016, right? Next, 1, the P of R is 0.094. Take the interval with the center equal to 1, and you go up to 0.094, right? Next, R is 2, 0.234. So again, interval with the middle given by 2, and you go up to 0.234. Then there's a 3. Take the interval with the center given by p, and you go to up to 0.312. Then we have 4 with so P of R is 0.234. There is 5 with probability given by 0.094. So here, and we're gonna go up to 0.094, and finally 6. So here's my interval with the middle given by 6, and we go up to 0.016. So here's 0.016. All right. So again, guys, here the idea is what we have to keep in mind is that the area end of the graph. So here's this is like the graph of my binomial. My binomial distribution, and the area end of the graph would be equal to 1, right? So just keep in mind, I'm gonna use this remark like in the next chapters. This is very important remark. So in this histogram, you know, the area end of the graph is 1. So the area here is 1, which is actually 100%. I mean, we did the same remark for probability distributions of for discrete variable x in the previous chapter, right? We had the same remark. All right, guys. So this is just for the graph of probability distribution. I mean the graph of a binomial distribution. Now we need to discuss the mean and the standard deviation of a binomial distribution. So mean and standard deviation of binomial distribution. So the mean and standard deviation of binomial distribution, they are just a particular case of so this is a binomial distribution. So mean and the standard deviation of binomial distribution, guys, are just a particular case of mean and the standard deviation of probability distribution. So remember the previous chapter when we discussed the probability distribution of a discrete variable x. So we had a formula for the mean x bar and the formula for the standard deviation, right, of probability distribution. So in the case of a binomial distribution, the formula for the mean and the standard deviation can be they can be simplified. So and actually we get very simple formulas. So the formulas of the mean and standard deviation of a binomial distribution, and they are actually very simple. And standard deviation of binomial distribution. So again, there are just a special case, or there are special case of the formulas we discussed in the previous chapter, of the formulas discussed in chapter 5. And we get very, very simple formula. So for example, the mean x bar of a binomial distribution is actually equal to n times p. Right. So this is the expected number. So x bar, this is the mean, all right, of a binomial distribution. It's just n times p. So that's the expected number of successes. So x bar, this is the expected number. This n times p, this is the expected number of successes. Right? So how many successes do we expect? And then there is the standard deviation S, which is also very simple. Standard deviation S of a binomial distribution. So S is equal of binomial. So, I mean, as you can see, guys, of course, you know, there are like, now we have like so many formulas, right? So just like of course, in the test, in the final, you're allowed to use your formula sheet. So you don't have to memorize all those formulas, right? So of a binomial distribution. So as I said, this is just for a special case of what we discussed in the last chapter, and we get a very simple formula. Actually, it's equal to square root of n times p times q. Okay, that's the standard deviation of a binomial distribution, square root of n times p times q. All right, so let's do an example. suppose, let's say about,
Everything inside the square root gets multiplied.
yes, yes,
Okay.
that's a multiplication here, actually. Thank you. That's a good point. So here it's a multiplication. So n times p times q. Yeah, so let's do an example. All right, so let's say about 35%, about 35% of all drivers they will tailgate before passing. Now, let's say, suppose you are driving. Suppose you are driving. You are driving, and you are passed by 12, and you are passed by 12 vehicles. All right. So, A, or 1, compute the expected number of vehicles. Compute the expected number of vehicles that tailgate before passing. Okay. So, so this is, so here in the top, guys, it says about 35% of all drivers will tailgate before passing. So, of course, if you take a driver, if you select a random driver, so either the driver will tailgate or he won't, right? So that's a binomial experiment. So a success would be when the driver will tailgate, right? So the success, so the driver will tailgate. So that will be a success. Or, right? Or he won't. Okay, so that will be a failure. All right, so now what's the probability of success? P. What's the probability that the driver will tailgate before passing? Well, it says 35%, right? As I said, like probability of success, P, is always like in the first sentence. So 35% of all drivers will tailgate before passing. So the probability that the driver will tailgate is 35%. So that's the probability of success. It's 35%. All right, so here, P is 35%. So then P is divided by 100, that's 0.35. Right. Failure, probability of failure, Q, it's just Q, it's just 1 minus P. So Q is 1 minus 0.35, and that will be 0.65. Anyway, we don't really need the Q. All right, so the question here, guys. Oh yeah, before that, the number of trials, N here. So what will be the number of trials? So it says, suppose you are driving and you are passed by 12 vehicles, and you want to compute the expected number of vehicles that tailgate before passing. So we have 12 vehicles, right? We have like a sample, or we have a group of 12 vehicles, right? So then the number of trials is 12. Is 12. right? Now it says compute the expected number. So again, guys, whenever you see the word expected number, that means the mean. Okay, so expected number of vehicles that tailgate before passing. So because that's the word expected number, so that's the X bar, the mean, right? And we just said the mean for a binomial distribution is just n times p, right? X bar, it's n times p when we have this binomial distribution. So X bar, so this mean, so X bar is n times p, right? This is multiplication. N is, we have 12 vehicles, right? Times P. P is 0.35, right? Because we said 35%, that's our probability of success. 35% of drivers will tailgate before passing. So P is 0.35. So this is times 0.35 or 0.35. So it's like 12 times 0.35, and the answer is 4.2. So what we expect here is at least, at least 4 vehicles they're gonna tailgate before passing, right? So that's the expected number. This is the expected number of vehicles that tailgate before passing. Okay, so out of the 12, you expect that at least 4 they're gonna tailgate before passing. Any question, guys? I'm gonna just check the chat.
Yeah.
Make sure
How,
there are-
when does
Yes,
the
please. Oh, I see. Sorry. Mhm.
the
Yes,
other
please.
formula comes into play? The one with the square root.
Oh, that's oh, sorry.
Is that separate?
Yes, that's a different formula actually. Yeah. Yeah.
Okay. 'Cause
That's the standard deviation. Yeah. That's
Oh,
different.
Oh, I was okay. I was doing that.
Yeah, I'm sorry about that. Yeah, so we have 2 different formulas, right? One for the mean, the expected number, and one for the standard deviation. All right, so we got our mean. Now, B, the second question. So this is a B, the second question. So it says, compute the standard deviation of this binomial. Compute the standard deviation S of the binomial distribution, of this binomial distribution. So we just said, again, S, it's useful because, I mean, if you have like 2 binomial distributions, then you can, again, you can measure, the spread of your, of your data about the mean using this standard deviation, right? And so in the case of a binomial distribution, S, the standard deviation is very simple. So we said S is just square root of N times P times Q. So like in this problem, S is square root of N. We said N is number of trials. We have 12 vehicles. So N is 12 times P is 0.35 or 0.35 times Q. Because remember, guys, Q, probability of failure, that's always 1 minus P. P is 0.35. So then Q is 1 minus 0.35. So the answer is 0.65. So Q is 0.65. Right. So then S, the answer. So we need to multiply first, right? Multiply first before taking the square root. So the answer is actually 0.65. So this is so let me just write it down here. So if you have 12, you know, times it's 0.35, just make sure that the answer is correct, 0.65. So if you just multiply the numbers under the square root, you get 2.73. And then you take the square root of this 2.73, and then the answer would be 1.65. Okay, if you take the square root of 2.73, then that will be 1.65, 65.2 or something. But anyway, yeah. So that's your standard deviation. All right. So just keep in mind, guys, whenever you have this binomial distribution, you know, this probability of success, etc., the mean and the standard deviation are very simple. The formula are very simple compared to, you know, the ones we had like on the previous chapter, like for binomial, like for probability distribution of a discrete variable x. So just to remind you, so I mean, again, these formulas are a special case of. So in the last chapter, the previous chapter, just to remind you, in the previous chapter, you know, when you have a probability distribution of a discrete variable, probability distribution of a discrete variable x. So we said, for example, discrete variable x. So we said, for example, that x bar, the mean, is the sum of x times p of x, right? You take each value of x and you multiply each x by the corresponding probability of x, right? So that's, for example, the formula we had for the mean in the previous chapter. But what I'm saying here is that, like, when you have this binomial distribution, so it's a special case of this formula, and we get, so if you have binomial distribution, then you can simplify this formula, and then your x bar would be just n times p, right? Of course, you can use this one. For a binomial distribution, you can also use this one, right? Because you have this table of the binomial, your binomial distribution, right? This table here. So instead of r, you have the, like, your x going from 0 to 6, etc. And you're supposed to multiply each x by the corresponding probability of x, right? So you can use this, of course, the formula we had in the previous chapter, right? But as what I'm saying here is that in the case of binomial distribution, the formula becomes very simple, and it's just n times p, right? All right, guys, I guess I'm gonna stop here. Thank you for listening. So I guess tomorrow we're gonna move to the next section or next chapter. All right, guys, thank you for listening, and hopefully I'm gonna see you tomorrow. Take care, everyone.
Hey, Professor, have a nice one.
You too. Thank you.
Take care.
Bye.
Bye, everybody.
Thank you. Bye-bye.
Thank you, Edward. Bye-bye.